All right, how did you guys do with this lesson?
I did okay, I hope. Hopefully.
I haven't had a lot of time to do it yet. I'm on number 8 of the quiz right now. I haven't looked at the lesson super closely yet.
I went through it. I just hope that some of it was a little bit of a stretch for my brain to like soak in. So I hope I caught the principles correctly at least.
Yeah, I agree. It was like everything came together and it was just like blew my mind. So trying to do the quiz was hard.
Yeah, it's really the whole, what they're really going to drive home is this idea of the relationship between the population distribution and the sampling distribution. That's what they're just going to drive home this entire quiz.
Okay.
Good, because I need it.
Yeah. It's a big ticket item that, because we're going to use the sampling distribution the rest of the semester. So
Okay, so why don't we start with number 3 and we'll just kind of work through. And if anybody, I was out to dinner with my mom. It was her birthday. I usually try to work on it when I get home from work, but I couldn't today. So I'm starting from scratch.
That's okay.
So
I'm jealous that you have your mom close enough to go out to dinner with her for her birthday.
I know, it's a blessing. I've lived away from her for the last 25 years. So I'm going to make use of it. We just went to Costa Vida and sat outside in California in 58-degree weather on February 1st. And I've lived in like Colorado and Wisconsin for the last 25 years. So I'm like, oh, I'm just outside.
Are you in San Diego? You're in San Diego, aren't you?
No, I'm in Sacramento, northern.
Oh, you're Sacramento. Okay. Yeah. So I'm south of you. It was only 58 there?
It was like 68 today.
70
but
here.
No,
it was 70 here.
Yeah. Yeah, it was warm, but the sun went down, so we were cold.
Yeah. And we don't get the variation as much as you do.
Right.
It literally varies like 10 degrees. We're in Monterey area.
In Monterey. Oh, I love Monterey. Oh man. My husband grew up in Southern California, so it's like our favorite place to go back and visit. And like it was like 30 degrees here in Kansas today, and I was like, why do we live in Kansas?
Why are we doing this? Yeah, I know. We used to live in Fayetteville, Arkansas, so right down the road
that's
from
just
you.
like 3 hours away from us.
Okay, who wants to start with number 3? Did you guys get that already?
I'll start since I think I might know that one.
Go
for it.
I got 0.175.
Oh, that's what I got.
Yep.
Oh, good.
Hey, you guys are no nonsense. Let's go.
Yeah. Okay, that's about as far as I have read. So, number 4, who wants a turn?
So I put that it couldn't be determined, but I'm a little confused on this concept.
Okay, so I'm going to help you because I think it's poorly, well, I shouldn't say poorly, I think it's hard to understand the wording.
Okay.
So the first one, that distribution of individual observations, that is referring to the population distribution.
Okay.
And it has a standard deviation of that sigma, that O with the little tail.
Mm-hmm.
The second one, the distribution of sample means, X bar, that's referring to the sampling distribution. And the sampling distribution has a standard deviation of that sigma divided by the square root of n.
Right.
So won't the sample
Does that make sense?
always be smaller because you do the square root?
Correct.
So it's
the sampling distribution standard deviation will always be smaller than the population standard deviation by that division of square root of n.
That helps a lot. Yeah. B.
Yeah. If they just said the population distribution standard deviation and the sampling standard, you'd be like, oh, I can read this.
Right.
That's why I'm thinking the wording is just kind of unfamiliar, but that's what they're basically referring to.
Okay, that was helpful. Thank you.
Okay, number 5.
I got the law of large numbers.
That's what I got as well.
Yeah. And so I always think about the central limit theorem is about if the sample size is large enough, the shape is normal. So the central limit theorem is about shape. And the law of large numbers is about if the sample size is large enough, the spread gets smaller. So central limit theorem is about shape and law of large numbers is about spread.
Oh.
Okay.
So sometimes that helps if you think about it that way to keep those two definitions square.
Yeah.
Sure. Okay.
I went back and forth between those like 5 times. I was like, okay, we've got to figure out the difference between these.
Yeah. Central limit theorem, shape.
Yeah, it's the shape versus like what the actual whole population looks like, right?
Say it again. Sorry,
so
you cut out.
It's the normal distribution shape for the central limit theorem, and then for the law of large numbers is the spread of the population, right?
The sampling distribution. It's about how skinny or wide the shape. So central limit theorem gives the shape to the sampling distribution, and the law of large numbers gives the spread of the sampling distribution.
Okay. Okie dokie. Okay. Okay, so we're on 6 now.
Uh-huh.
So I got 1.045 for that.
Yay, that's what I got too.
Okay.
Okay, and the only thing so this is just about Diane. Because it's just about one data point, then you know you're dealing with the population distribution.
Right.
Oh, okay.
Does that make sense? And that'll come into play because you're just saying, hey, I went in and I just grabbed a single data point. So the distribution that has every data point individually graphed is the population distribution.
Yeah.
But yeah, so it's Diane's score of 160 is 1.045 standard deviations away from the mean. And what's the probability that you would randomly select a score above Diane's? This is question 7.
I have 0.148.
That's what I had as well.
Okay, so 14.8% chance that you would randomly select a person that had a score above 160.
Right.
Okay.
Okay. So
Now question 8 is going to shift gears here, and instead of a single data point, we're looking at the average of 5. So now we're talking about the sampling distribution, not the population distribution anymore.
Okay, so is this where you would take the standard deviation of the population and divide it by the square root of 5?
Correct. That'll give you the standard deviation of the sampling distribution.
of this distribution, yeah. So I got 2.338 for that one.
Wait, so you need to find the sample deviation and then find the z-score?
Correct. So first you have to find what we call the X bar, which is the sample mean of those 5 data points.
Right.
And then once you
would the
find
mean not be the same
X
as
bar,
would the mean not be the same as the population mean? Or it would be, right?
That
Not the
for the sampling distribution, yes, but
for this one, the mean that they gave us above was 150.8, but on the sample size that they gave us, it was 160.
so there's the sample mean and there's the population mean.
Mm-hmm.
And so, yes, the sampling distributions got that same, it's centered right around that 150.8. But instead of looking at an individual data point, we're looking at the average of 5 data points.
Of the 5.
So we
right?
would
That
take
make
the mean of
sense?
160.
Yeah.
Yeah.
So that's when you do like the 160 minus the 150.8 divided by the standard deviation of 8.8 divided by the square root of the 5 for the 5 samples that we took.
Oh my goodness. Okay.
That makes sense.
I'll probably have to wrap my brain around it when we're done.
How about if I draw it out, would that help?
Yeah, I'm a visual learner, so that would help.
Okay, so let me just show you. So, because I think that for me, it's so there's basically you have basically 2 scenarios. You either have the population distribution, and excuse how bad I draw, says I'm the most horrible drawer of life. Oh, whoops! I got.
We're not gonna
my
complain.
little drop.
No.
Wait, you see, I mean, he will die. I'm so bad, especially on this computer. Okay, let's see if this will react here.
My 5-year-old draws better than you're probably okay.
Come on, Mr. Pen. Oh, there we go. Okay. All right, so you have, and then I'm a lefty on top of it. So, okay, so the population distribution. Okay, in this case, you get a bell shape, you get a mean here, and then you get this you get standard deviation that's equal to sigma, right? Or you get a sampling distribution, which in a sampling distribution, that means we're taking averages of so many sample data points. It's got the exact same mean, that mu, but its standard deviation is actually thinner by this square root of n. So when we talked about just Diane all by herself, we're dealing with the population distribution because she's just a single data point. But then on the next one, we went out and we took 5 people and we found their average, and that's 160. So now we're working in the sampling distribution because we're taking an average of so many data points. So it's still got that mean, but its standard deviation is now that. And we're trying to figure out if we have an X bar equal to 160, because you take those 5 data points and find them mean it's 160. And then we're trying to figure out what's the probability of randomly selecting 5 people whose average score is above 160. Does that make sense? Or does that make it more confusing?
No, it makes more sense.
So it's either you're dealing with the population distribution or you're dealing with the sampling distribution. So if you're dealing with a single data point, you're dealing with the population distribution. And if you're dealing with a sample of size n data points and finding their average, then you're dealing with the sampling distribution.
So this is gonna sound really basic. I mean, it's probably a really stupid question, but between population deviation, what did you say, population and sample?
Mm-hmm.
That's telling us what formula to use. Is that right?
The relationship between the population distribution standard deviation and the sampling distribution standard deviation is just the sampling distribution will be skinnier than the population distribution by dividing by the square root of n. Is that what did I understand you right?
Yeah. I just, like when I see more numbers and they were taking an average, that helps us to know which one to hone in on.
Yeah, that it should say, oh, okay, I'm working off of this picture because I'm taking an average of so many data points. And then you're basically going through the same exact scenario to find that probability. You still have to find a z-score And it's the same thing minus the mean divided by the standard deviation, but this is your standard deviation now because you're dealing with the sampling distribution.
So it's the sigma divided by the square root of the sample.
Yeah, and then be very careful on your order of operations on that.
Yeah.
Because I see lots of mistakes when on that. So you want to be super careful. You want to do the subtraction.
It helps if you do it in Excel.
And
That's
then,
the only way that I can keep it straight.
oh, is that right? And I do, I won't tell you because that might confuse you. Because I know this is double, so I'll do division and then I'll multiply. But you want to, so just be careful, however it works in your brain, but you want to make sure you put parentheses around those and divide. So you find a value here. This is 9.2. And then you find a value for there and carry about 5 decimal places. So 3.9355. And then do the, does that make sense?
Sweet.
So what you guys got?
That's what I
That's
got.
what Megan got.
Okay.
Yeah, that's what I see now.
So
Okay.
All right.
Thanks.
Dee Dee, are you getting it? You seem quiet tonight.
You know, I got one. I keep getting wait, 10th, 100th, 1,000th off. I'm 1,000th off. Is it always supposed to go rounding? Are we always rounding up, no matter what?
No,
you're right to the decimal place.
Like I got 2.3374. So
yeah, it's fine. It's probably just because I rounded mine to 3.9355, and if you carried the exact value, yours is going to be a little lower than mine.
so it's okay if it's that 1,000th off on the quizzes because I was off on the number 3 as well by 1,000th.
If you
It depends on the question as to whether there's a tolerance, and when there's rounding, then they'll have a tolerance. If there's an exact answer, then they're not going to have a tolerance. So like if you were using the empirical rule, that 68, 95, 99.7, that's not going to have a tolerance because those are very specific values. But when you're dealing with these irrational numbers like square root of 5, they're going to have a tolerance coded in.
Oh, that's nice that they do that.
Okay.
But too early. I mean, you want to carry those 5. I mean, if I did it exact, if I didn't do the rounding, I would have got, I would have got 2.3377. So I still would have rounded it 2.338.
Okay. I've just been carrying the 3 numbers, and
You want when you do the math, you want to carry probably 5 numbers.
okay. Okay. Good to
When you
know.
answer on the quiz, answer to 3, but doing the math, rounding to 3 is a little too tight.
Okay.
That's one reason why I use Excel, because while I go through it, it doesn't round until the end, and then I can round it down that way. So it's taking it out super, super far without me having to see it. So then at the end, then I round it down, or round it to 3 decimal places or 4 decimal places, so that I don't have to think about how far out I'm taking the number when I'm actually physically doing the math. But it just takes a little bit of stress off of me.
Okay, so that was number 8, right? And that was very helpful. Thank you. Number 9. Did anybody get that one yet?
Is that 0.0097?
Yep, that's what I got too.
Okay, good. Me too.
Yeah.
Okay. Number 10. So you've got some information to use for the next 5 questions.
Right, sorry, I lost the connection again. It keeps going in and out.
Did you get number 9, Dee Dee?
Let me see. I got 0.0997. Is that right?
It should be 0.0097.
0.0097.
Yeah.
Oh my gosh.
0.00.
0.00997.
Just 1 9.
How'd I miss?
0.0097.
Oh my gosh. That's
I'll stick
bad.
it in.
Somehow
You
I
might have-
missed that one.
Typo.
Yeah, or did you make sure you shaded above and not everything below?
Oh, okay. I'm just reading it wrong.
Okay, good. That's what I was hoping was what happened.
It's actually up on my screen right now. 0.0097. Okay, I'm so sorry. Just ignore me. I'm just really tired. You just keep going. Let's just keep.
That's funny.
Okay.
Okay. Number 10.
I got approximately normal.
That's what I got.
Yeah, and
As
that's see how it says what is the shape? So that's central limit theorem that is allowing that to happen because it's about shape.
Right.
All
Cool.
right. 11.
I got 0.1, but I'm not sure if I'm correct.
Sorry, my internet's bad at night. What did you say?
I got 0.1, but I don't know if that's right.
Remember, the mean of this sampling distribution is exactly equal to the mean of the population. Those values are exactly the same.
So I put 3.5 because that's what they gave us in the problem above.
Correct. Yeah, the means are always going to line up. Always. That mu value, that population mean, will also be the center of the sampling distribution.
I think the wording of the questions just has me rethinking and not because I know that, but yeah,
overthinking it.
I agree with you. I think it's really confusing. What's the mean of the distribution of the sample means for all the possible samples? And you're just like, oh my gosh, what in the world?
Like,
I mean, all it needs to say is, what is the mean of the sampling distribution? The end.
Yes. Yes. Okay.
Okay, number 12.
So this one's just asking you for the standard deviation of the sampling distribution. Just cut through all the chase of that. There's like, so the mean of the sampling distribution was 3.5. What's the standard deviation of the sampling distribution when you have a sample size of 81?
So I got 0.078.
Oh, good. Me too.
Perfect. Yeah. Again, they're just trying to drive this relationship home between the population distribution and the sampling distribution. They're just going to keep pushing that to kind of get it clarified in your brain. So perfect.
13.
So I got 0.005.
That's what I have too, but I'm feeling really not confident tonight.
That's okay.
I can't even see right now.
So I just plugged in I just plugged it into that applet thing.
Yeah, I find a z-score.
Yeah, I find the z-score, plug the z-score into the applet, and then
Yeah.
and then anything that's less than the z-score, then so that came out. So that area was 0.005 on the applet.
0.005.
Yeah.
Okay, so then 14 would be the what's on the other side. That
So, yeah. So everything not smaller than 3.3, but the greater than. So the area to the right hand side of that z-score then. So 0.995 is what I got.
That's what I got too.
Yeah.
Okay.
You can either actually shade it off the applet, or you can just use that idea of the complement rule. Like, the bell curve has to have an area of 1. And if to the left was 0.005, then to the right has to be 0.995.
Right. That's a good double
So
checker.
either way works totally fine.
Okay.
it always helps when you know how to use the applet. Remember last time I'm like, I keep getting every answer wrong, and I didn't have it shaded correctly. Anyway,
Yeah, there's a learning curve on the applet for me
lost
too.
that on me. All right, 15.
I have 0.782.
I have 0.055.
Ugh.
Okay, first tell me what you got for a z-score.
Me or Dee Dee?
Dee Dee.
I do not know. Do not ask me that.
Hold on. Well, I did it on my other computer, so hold on.
Oh, okay. I got it. On the z-score, I got a negative 0.27715.
Okay, so we got to go back and work on that because your z-score is not right. So tell me
Okay.
how you got your z-score.
I took the 177.6 and I
Okay.
subtracted 185.
Perfect. That's perfect.
And then I divided that by the 26.7.
Divided by square root of 48. This is
And
it.
then the square root of 48.
Yeah, because remember, this is looking at the average of 48. So you're in a sampling distribution. This isn't the
that's right.
population. You're not looking at
Okay.
a single boat. You're looking at the average weight of 48 boats. So your standard deviation needs to be the 26.7 divided by the square root of 48. That
Okay,
makes
so I
sense?
missed that one. That step. I didn't do that step.
Yeah, that's always your key. If you're like, if you're looking at an average of a bunch of different information of a sample size of n, then you've got to move into that sampling distribution picture.
So Megan, what was your answer then?
So it's 0.055.
So what's your, step back, that's totally perfect, you got, but step back and let's just make sure we have the same z-scores.
So let me do it really quick. Hold on.
Well, you must have had it, are you?
Yeah.
But I just wanted, because that's kind of a checkpoint before we get to the probability. If we all have the same z-scores, then we can go. So what everybody get for a z-score?
Hold on, let me try. 177.6 minus 185. And then we go. Let's see if I can figure out how to do it on this computer. Where's my Excel? Hold on. Bear with me.
I got to give you, look, this is how I'm still like, on the 84. Like, I don't even need, I'm like, this is how I do everything.
That's how I am with
I still
Excel.
carry this thing around.
My little buddy.
I know.
Okay.
Excel and I have not made friends.
Oh. I had to learn how to program
we are
Excel.
acquaintances.
And so
yeah, my husband loves Excel, but I'm Yeah, yes. And it's good, but this is like, I trust this one. Excel, I'm always like, I'm not so positive. I trust it.
Yeah. Doesn't want to look for that. Preparing to install. What's going on? No. Okay, so square root of 5, then the square root of 5 is
Square root of 48.
2.
You want square root of 48.
Oh,
48.
Yeah, thank you.
Yeah. Yeah, 48 commercial boats.
40. And then 5 was on the other question. Okay.
Yeah.
So it is 26.7 divided by the square root of 48. 6.928 divided by 26.7 divided by 6.923. 3.85. 3. So,
Okay, so the z-score was negative 1.92.
Yeah, perfect.
Yeah.
Yeah.
That's what I got.
Perfect. Yay.
Good
Okay.
job.
So now get in your applet, and when they say extreme or more extreme, what they're telling you to do, that's what we consider a two-tailed test. So they're telling you, hey, find your z-score and then shade the extreme left and the extreme right tail.
yes.
Oh, okay.
So 0.0549 is
Perfect.
for both.
Yeah, and then round that to
Rounded.
so round that to 3 decimal places.
0.055.
Yep.
Perfect. That was perfect.
Oh,
You guys
that was
did
so
awesome.
awesome. I feel like I just learned something. Like I got that one.
Yay.
Because you guys told me what to do. That was awesome. But hit the math right here on my paper.
Hey, you got the answer. We didn't tell you what the answer was.
Great way to end.
Sorry, I was quieter than usual. They're having mutual at my house.
Oh, what?
Oh,
No.
That would explain it, wouldn't it?
that's
All right, awesome. 100%. Woo! Thank you.
Good job.
Yay.
Who's gonna do group leader next week? I'll find it on the western front.
what are we down to? Alec or Megan, right? You two are the
Nose
last.
goes.
Your nose goes.
What did he say?
He
Nosies.
said nose goes.
Oh. I'm still
So I
trying to
guess
fix
that-
my Hangout on my computer, but I have to do another meeting, so I'm committed
If
to
you
fixing
want-
it this weekend.
Okay. If not, just email me and I can do it for you.
Okay, but I'll plan on doing it.
I got
Okay.
one wrong. What was number 12? I put 0.78.
It's 0.078.
Ugh, darn it.
Yeah, because it's 0.7 divided by the square root of, I can't remember now, 5, was it?
5. Was that the 5? I think
Yeah,
that was the
never
5.
mind. It was, there was,
Mhm.
I'm like, wait. Because it was the sampling, oh no, that's not it. It's 0.7 divided by, I don't remember what the sample size was, whatever it was.
81.
Oh,
So,
wait. Oh,
right,
81.
that one was the sample
Yeah,
size.
that's it.
81.
81, yeah. 0.7 divided by square root of 81.
Well, thanks for coming to our group meeting, Sister Lemon. That was helpful.
Yeah.
Well, thanks for letting me come. You guys
I
were
didn't really
awesome.
have a choice. I could have like hung up really fast and sent you guys a new link. Backdoor link.
That would have been evil.
Like, whatever. All right. All right.
All right, have a good weekend, everybody.
All right.
All right.
Thanks,
Take
guys.
care.
Bye.
Thanks.
Bye.
Bye.